Okay, we're going to do a video that covers force and transmissibility. This is chapter 3. It starts with rigid bodies, and we're going to start understanding how to deal with the forces internally and externally, add up and multiply vectors, and find triple products and that sort of stuff as we go here. So this is similar to Chapter 2, but it's really got a more design focus than just some of the basics. But it still has some things that we need to understand. Um, so let's start with simply a rigid body. Okay, and this, if you're reading the textbook along, you'll see this. Um, it is an object that does not deform. Okay. By that I mean it doesn't change shapes, it doesn't squish. It's basically it's think of uh, let's see, a wooden block. It has the shape that it has. No matter what forces you put to it, it will not change. Now, that's a theoretical definition. I want to just tell you ahead of time here that almost every block or every material known to mankind has some sort of movement to it, and it will change shapes and do all kinds of things down the road. So we want to be careful with how we use that phrase. It's not just a simple um, we do this and everything's perfect and the world stays there. Molecularly, the molecules will slide and shift past one another, so we can get things to deform. But in a simple understanding of statics to start with, using a phrase rigid body makes things a little simpler and provides you a good starting point. So that's why we start with this. Okay. Um, all right. So we have a couple forces that we can do with these things. So let's start with the forces that can act on a rigid body. There is external, those that exist to okay. Designed to push or pull a rigid body. I suggest you also find your textbook and read up on this section, but it's useful. But it'll give you generally it's things that cause the rigid body to move in a direction that isn't at rest. Okay, so give you an example here. Let's put a little block right here. I put a force there, call it P. This thing is going to move in, um, it's going to slide along on that direction. Okay, and that's the movement, and that's the force that's causing that. Okay, and we're going to spend a lot of time with that when we get to chapters 4 and 5, and you want to make sure you are aware of that. And then the other one is this internal. So So if you suspected that there was an opposite to external, you're absolutely right. Okay, and okay, so these are forces that hold the um, rigid body together. It's kind of an interesting thing to do, but I'm going to do this. We're going to start with this, and I'm going to do this one based on temperature so you can kind of get this. So as this part is here, let's call it P1, and we'll put another one over there, and we'll call that P2. But then we can have one here, and that's P3. Okay, and then we can have one at the top too. But I'm going to take this. Let's say it's 70 degrees C. Okay, so it has some temperature to it, and the block has some internal energy of the molecules. Just like with water and ice and all that sort of stuff, temperature affects the molecule movements. Internally, the molecules are forcing to push on the outside of this surface as it warms up. Now, what happens if we take the same block, and I'm going to do this one in a different color here. Let's say we decide to do this, and I'll explain it here in a second. I just want to get this drawing done. Okay, and we start out like that, and then we apply this and that and that. So P1 primed, let me get this a little bigger here. P1 primed, P3 primed, P2 primed. Okay, start out with the same block, but now we take it and turn it into minus 20 degrees C. Okay, so we're freezing it down. The block is going to shrink because the molecules are moving closer and closer together. That builds up an internal force inside that, and then we have the internal forces. So in that case, it's going to try, and this thing will shrink so much, and then it will crack in half or do something like that. But as we warm it up, those internal forces are going to spread it out. So those are internal forces. Okay, simple concept. We'll come back to these, so don't get too hung up. Just try to remember them as we go through statics, and you'll get the hang of what you need. Okay. All right. Where are we going here? Let's see. What else I want to talk about with external forces? Well, let's do this. I want to talk about Newton's laws of motion. Okay, so for an object to remain at rest, there must be an equal and opposite force. Okay. This will come into play a lot more when you take a dynamics class, but his law in this particular case actually applies. So let's do this. I got my original block up here that I had force P on. And if I only have this force, I'm going to move to the right. But now if I give it a opposite force, we'll call it P prime, then as long as P is equal to P prime, the object will be at rest. No motion, no movement, forces are equally opposite, and do all that kind of stuff. Okay, but as soon as P is not equal to P prime, the object moves. Okay, and what we're looking at is this is statics, and this is dynamics. Okay, just so you get some perspective on that as we go forward into the future here. Okay, all right, now here's the coolest thing about static forces. Okay, if we think about it, we want to move a force from one place to another so we can actually see what's going on. We have a principle that we call, let me write it out. Okay, so we're going to play with this one quite a few times. Okay, first they have to be equivalent forces. Okay, there's an I in there someplace. I missed that. Let's try that again. Okay, so we have to have that, but what we're going to do is this. So I'm going to take any old shape. Yeah, just draw a blob. Okay, but if I have a force acting on, let's get some color in here. Let's say I act down this way on this dotted line. Okay, so we're acting through the center of this. And what the heck, I'll put the force in here. If I have a force here going in this direction, F, okay, and I want to move that force from there to some other place on this line, as long as I'm moving on the line, I can create this force. So we could call that F prime. Okay, so I am transmitting F to F1. So F moves to, not F1, F prime. And it's equivalent. Okay. The best thing I can tell you right now is, and believe me when I'm telling you this law works, but it's one of those things that you will discover when you do dynamics, and it'll be proven out to you then. I usually don't like just telling people, believe me, because I'm an engineer and I know what I'm talking about. I would like you to actually have full understanding, but at this point, till you get the dynamics class, you're not really going to get full comprehension. Just know, as long as we move F down the line of action, we can go to F prime into that position. Okay, so basically we're just moving position. And I guess as long as I'm doing this, let's call this the line of action. That'd be another thing that'll help you do that. I'm not sure the books ever explain that, but it is one of those things that makes sense. Okay. Alright, so we need another little example here, and then I'll kind of wrap up this section here. But let's take let's take my favorite car, which is easier to draw, is a VW Bug, which isn't really what this turns into be, but it is what it is. Okay. and I'm going to draw an equivalent car over here. Maybe it's not the same looking, but it's generally what it is. Okay. All right, now I'm going to apply some forces to this. So I have a reaction force here, so I'm going to call that R1. We're going to have a reaction force there, that's R2. Okay. Now on this same car, it's going to have the same reaction forces as the tires hit the road. And that definitely wasn't a 2 over there. Let's make that 2. Okay, so those will remain the same. The other bit that's going to stay the same on this is if we take the weight of the car, we're going to call that W, at the center of gravity. That'll become important too down the road here, and we'll talk about center of gravity in a couple lectures. But if we start with, I'm going to do this one in green. If I start with a force here that's pulling it, so let's call it F, and I could also take the same car and put the force back here and call it F prime. So in this one, force pulls, and this one, the force pushes. Okay, but each of those are going to cause some movement. Okay, so what else do I want to explain about this? Well, the only one that's getting is transmissible is the F forces. Okay, the R2, all that's going to stay the same, and I left the W off up here, didn't I? That's W, and we're going to find out later down the road. As long as we're going to have some fun here, I might as well teach it down the road. If we have a reaction at the back wheel, R1, and we have the reaction here, R2, and we have a force that's W pushing down, we have a static problem to solve. Okay, and that's where forces come in and why we do that. Now, this is everything acting in the Y direction, but now when I go back to the green one, the forces here, these are everything acting in the X direction. So we're trying to move it so it makes more sense to you. Use it however which way you want with this. But the real trick to this one as you use this is remember that as long as the force is moved in the line of action and is an equal vector or equal vector, then it's equivalent and you can move it anywhere you want on that line of action. So make sense? That's really the short concept of that thing, and there's a whole bunch of things we can do down the road here that just kind of feed into your appetite. But let's say we do this. Okay, so I got a force here and a force there, and we're going to call this point 1, point 2, and as long as P1 and P2 are equal, we're good. Now, because of that, I can also use the same logic that I've used above and put P1 there and put P2 there. Okay, and this is point 1 and that's point 2. Okay, doesn't matter whatsoever. Okay, and I can move that around anywhere I want on that, and that's kind of what one of the figures in the textbook trying to teach you, but it's really simple to deal with that. Okay, and that is the coolest and easiest thing about that. Okay, I'll leave that be, and I'll get another video started for you, and we will see where we go.